All right, so apologies for that little hitch with the mystery of the missing slides. So my name is Ginger Coons. I am a graphic designer turned researcher. So graphic designer a number of years ago. Then I somehow became a social scientist, and by somehow I mean through 6 years of grad school and hard work, because that's normally the somehow. And I've spent the last several years working on projects that have to do with the intersection of, I would say, critical theory and digital fabrication. And so what I'm going to talk to you about at the moment is this question of digital fabrication and the custom. So something that people have been mentioning a lot in the last day and a half. How do we use digital fabrication technologies to customize goods? But I do have a preamble, and I say sorry, not sorry about this, because this is a talk that is a bit more theoretical. I'm not talking about any projects I've done. If you want to talk about 3D printed prosthetic legs, we can talk about that later, but that's not what this is. So it's a bit theoretical and it's a bit historical. You can think of it, in fact, as a way of framing some of the problems that we're dealing with here around commonality and difference in goods. So I'm going to start with a little anecdote. And with apologies, I'm going to read this anecdote to you because I really like how I wrote it. So there's a game I like to play with myself. I like to look at charts of average height in countries around the world to see how much taller I am than the average woman. Of course, that data isn't perfect because, statistics, averages, meh. A lot of the available information is old, since most countries don't make a habit of doing mass-scale anthropometric studies of their people on a regular basis. And average is average, right? So there's a range that isn't being communicated by these averages. Short of looking at the percentiles for the charts, all that the average tells me is how tall I am compared to a notional woman, who is the aggregate of all of the women in a country. But bearing those limitations in mind, I find it fun to look at these lists, like these lists, and to try to figure out how totally non-normative I am in a given country and in the world. So I play that game, and I will say that I win at that game because the only average woman who even gets close to my height is Miss Bosnia and Herzegovina, who is 171.8 centimeters tall. So she's about a centimeter shy of me. So I say, take that, world. But there's a second game that I like to play when I'm looking at those charts. And that's the am I the average man game? Sometimes I am. I am, in fact, the average man in Brazil, based on 2 studies and taller than him in 2 others. Likewise, I'm the average man in Hong Kong, sometimes, and taller sometimes. Ditto Iran and South Korea and Portugal. In Spain and Turkey, I'm the average man in some studies and shorter than him in others. But I am, in fact, the average man in the United Arab Emirates, almost on the nose. I have him beaten in Azerbaijan, and Bahrain and Bolivia and Cameroon and Chile and China, except Beijing, and Colombia and Cuba and Egypt and Gambia and Ghana and India and Indonesia and Iraq and the Ivory Coast and Japan and North Korea and Malawi, Malaysia, Mali, Malta, Mexico, Mongolia, Nigeria, Peru, the Philippines, Qatar, Romania, Saudi Arabia, Singapore, South Africa, Sri Lanka, Taiwan, Thailand, Uruguay, and Vietnam. This may give you the impression that I'm obsessed with my height. I'm not, really, not actually, except in as much as my height, compared to the average woman, affects my quality of life. Buying clothes is a bit of a bastard. I'm a solid 10 centimeters taller than the average Canadian woman. I'm Canadian, by the way. And 11 centimeters taller than her American counterpart, which you'd think might be fine, given that models are tall, taller than me. But I'm not a model, and that's not how the clothing industry works. I'm a relatively proportionate adult woman, a little bit overweight if you go by my body mass index, but pretty average on the whole. Just kind of giant, just a little bit bigger than everybody else, which is why the average woman fascinates me so much. Because governments collect anthropometric data in part for public health reasons. It's useful to know where your citizens are at in terms of risk factors, like height and weight or like waist circumference. But there have historically been other reasons to collect that data. In the United States, the longest running anthropometric data collection project is run by the military because uniforms that fit, cockpits, and other body-adjacent user interfaces that work with the bodies of your soldiers need standards, and those standards depend on knowing the measurements of the military body. So I'll stop reading now and just talk to you. I should tell you what anthropometry is, since I've thrown that word around a little bit, and it's pertinent to the rest of the talk. So anthropometry, if you want to go to the Latin, is the combination of anthros and, well, metrology, frankly. So anthropometry is sometimes called physical anthropology or anthropological statistics, depending on what era you're in and what country you're in. And it is indeed the science of measuring human bodies and their constituent parts. So when we measure ourselves, when we measure bits of ourselves, we're doing anthropometric studies. We're doing anthropometry. And like many of the things that we take for granted, and I promise you, even if you have never heard of anthropometry until today, you do take it for granted. Anthropometry has its origins in the Enlightenment period and in the rise of scientific rationalism as a system of thought. So from the Enlightenment, we get the discipline of anthropology, which is the study of humanity, or as it was characterized at the time, the study of man. And from anthropology, we get the subfield, anthropometry, the measurement of man. Standards, one of my favorite things, are tied to anthropometry. And anthropometry is in turn tied back to standards. When I say standards, I mean, for our purposes here, a set of procedures or rules that renders a practice explicit and transportable. That's a general definition of standards. So whether it's a document explaining how something should be done, or an object, like a prototype kilogram, as you see behind me, a standard allows actors in different and separate settings to achieve some degree of sameness in their activities. It lets us talk to each other. So, for example, if we want to measure humans, we need to have systems of measurement. If you want to measure Canadians, Canada needs a standard for measurement that applies across the country. If Canada wants to talk to Spain about how tall our respective citizens are, we need a standard kind of measurement that is applicable across countries. So, for the time being, we have the metric system, a wonderful invention of the French Revolution that almost everyone in the world except the Americans uses. Silly Americans. But the thing is, with something like this, it takes an international agreement on a system of measures for multiple countries to be able to talk to each other, and that's a very big deal. Now, my friend Edward Muybridge, not actually my friend, he's been dead for some time. Muybridge is a fantastic example of how anthropometry serves the project of modernity, because it's one of the things that we use to understand how bodies work and what our bodies do at work. So Muybridge is a fantastic example because he used photography in its very early days to photograph human subjects, and this is Muybridge himself, who really got into his work. They were almost always naked, by the way. He's also famous for photos of birds in flight. But what's notable about Muybridge's work is you see these little tick marks near his feet, right? Because what we have in Muybridge's work is this example of the attempt to scientifically study and categorize human movement. That's Muybridge, our good friend Muybridge. Another non-friend, good old Frederick W. Taylor, right? A contemporary of Muybridge's, and maybe a slightly more sinister example, because Taylor, good old Freddie Taylor, gives us the idea of scientific management, or he popularizes scientific management, which is, of course, the idea that we can categorize and define the way people move and do things at work. We can break work tasks down into little understandable components, and, of course, the sinister side of that, we can take agency away from the worker and put it into the hands of the manager. The manager becomes the subject and the worker his object. So, yay Taylor. And one of the things that Taylor did was he made use of time and motion studies, so stopwatches and watching people's actions, to define and to create recommendations about how much work a manager might expect a worker to do in a given period of time. So he's very famous for a study about a pig iron handler, so picks up pigs of iron from a pile, moves them to a train. How many pigs can you move in an hour? Right. So this is the legacy that Taylor gives us. Every time you punch into work, you can thank Taylor for that. But that's the point. The work of people like Taylor and Muybridge and their contemporaries still informs the way we think of how people are in the world. It's a big deal. So the problem is there are non-standard bodies, right? We can't see the majority of the tallest man in the world because, hey, I've cut this at the scale of a normal human. And that's the point. Just as I am taller than the average woman in the country I live in, the tallest man in the world has a huge amount of trouble buying pants, right? I mean, think about that. No one carries his inseam, you know? Even if he's got a comparatively normal waist and is just really lanky, no, the pants are gonna just be hitting his calves, right? It's a problem. It won't look nice. He goes to a tailor, presumably, and back when this poster was made promoting the appearance of the tallest man in the world, he would have gone to a tailor, because that was relatively commonplace, though it is not now. So, human beings aren't standard. You don't have to be the tallest man in the world to not be a standard human. We're often unstandard in far smaller ways. And we're increasingly realizing that. So beyond just straightforward areas like height, though height does matter, because average height is how we define our built world. Why is a door as tall as a door is? Because someone did an anthropometric study and defined the height of an average human and said, this is a reasonable height for a door. Why do airplane seats have the pitch that they have? Because someone found out what the average leg length of a human is, right? Why does our clothing fit the way it does? Again, right? Standard humans. Beyond that, beyond simple things like that hugely affect our lives, there's areas like how individuals react to pharmaceuticals, something that we're increasingly realizing differs. There's things like what kinds of nutritional requirements someone might have. You know, if I'm a triathlete and I'm training every day, chances are good I have higher requirements calorically than someone who works on a computer all day. If I'm 8 feet tall, I definitely have higher caloric requirements than someone who is 4 feet tall. Big, big, big differences. Now, I'm going to take another little detour into a cute little story. Has anyone here ever heard of Oliver Smoot? Hands up if you've heard of Smoot. Okay, Smoot's pretty great. Smoot was I apologize to any Americans, I might get this wrong. He was a freshman, so he was in his first year at MIT back in the 1950s, and he was in a fraternity. And the elder members of the fraternity decided that it would be a hilarious pledge prank to measure out the Harvard Bridge, which is a really long bridge that connects Boston and Cambridge in Massachusetts to each other. So they decided they would measure the bridge in smoots. Now, a smoot is about 170 centimeters long, because that's how tall Oliver Smoot was at that point in time. So the exercise of measuring the Harvard Bridge in smoots involved Oliver Smoot laying down. Someone would mark where his head was. He would get up and lay down with his feet at the previous mark, and it would go on. Eventually, he got so tired that they had to pick him up and carry him from smoot marking to smoot marking. But they did it. They measured the entire Harvard Bridge in smoots. And to this day, his old fraternity at MIT continues every year to go out and repaint the smoot markings. Like this one, real actual photo of a contemporary 100 smoot marking on the Harvard Bridge. And this has gotten so ridiculous that, in fact, when the city of Boston redid the sidewalk on the Harvard Bridge, they made the paving stones smoot length. This is the one place in the world where paving stones are 170 centimeters long because of Oliver Smoot, 60 years ago, laying down over and over again on that bridge, right? But this is an interesting thing because this is one funny little case of one human having a standard built to his own specification. Oliver Smoot is the standard for the paving stones on the Harvard Bridge, which I think is spectacular. And it's just a wonderful added bonus that he grew up to be the president of ANSI, which is the American National Standards Institute. Genuinely. I think that's just, destiny in the making, right? But the point here is that we often deal with the non-standardness of bodies by resorting to customization, which is really in part what we're talking about here, right? When we talk about digital fabrication and objects, one of the compelling arguments for digitally fabricating an object, unless we're talking about things like distance and portability, one of the big use cases is customization. We make individual things because we are individual people who don't feel well served by the mass products that exist. It's an issue. Now, the Smoot markings are an example of that. Frivolous, but hey, they are about non-standardness. I think Smoot was a bit short, actually, because I'm 3 centimeters taller than him, which I think is ridiculous. But point being, we used to do this. This is one of those cases, with apologies to Turek, where there is a historical precedent for doing a thing that we are now moving back to. Unlike that argument about the software commons, we did previously customize as a matter of course. So this is a little excerpt, to me the important excerpt, of a painting by Mary Cassatt from the 19th century. And Cassatt is one of the few people who painted scenes like this. And this is a woman having a dress fitted by her dressmaker, right? And Cassatt was painting something that was a normal part of her life as a comparatively wealthy woman in the United States in the 19th century. This was pretty normal if you had the money for it, and lots of people did have the money for it, and if you didn't, you made your own dresses, or your mother made your dress, or your sister made your dress, or you all got together and made each other's dresses. And the point of this kind of customization is that pre-industrial dressmakers have this wonderful, and they are this wonderful case study of a production process that takes heed of individual differences, which is a big deal. So a dressmaker works with her client and with the requirements presented by the client's body to build something entirely individual and to build something that lasts. The customized dress has staying power. You rework it over the years. You build in allowances in the seams so that you can let it out when you get bigger. It is a dress for you. It's not a dress for anyone else. Because this also predates, in large part, again, talk to me about clothing for sailors in the 18th century, but in large part, at least in women's clothing, this was entirely the norm for hundreds of years in most Western countries. I would even hazard to say all Western countries that had a significant enough flow of money. And this predates the existence of numbered sizes in clothing. You could not, at this point in time, go into a store and pick up a size 10 and have any belief that it would fit you, because a size 10 didn't exist. That was not a thing. Now, the dressmakers are back, kind of, not really. It's complicated. Oh, damn it. Sorry, I did my PNG wrong. Ignore the box of little checkers that you wouldn't have noticed if I hadn't mentioned it. So things like Indochino, which we see here. This is an American company that sells customized suits online and sometimes in stores. They have storefronts now. But they started out and ran for a number of years as a purely online retailer. And what Indochino does, in addition to letting you do things like customize the color of your jacket lining, they take your measurements. And by take your measurements, I mean they provide visual instructions on their website for how you can measure yourself, and then you input those measurements, and they make you a custom suit. And they do this using digital fabrication technologies like CNC cutting, right? So your measurements get plopped into a pattern which feeds out to a computerized cutting machine that cuts your pieces, that then get worked up into your suit, that then gets sent to you. So it's like a digital, contemporary, mass production, except mass customization, version of the dressmakers in terms of the attempt at one-to-oneness. Now, that requires manual intervention from you. You measure yourself. You input the measurements. Other people have tried it in different ways, and it's happening now. This is full-on, ongoing. We're now scanning people in order to produce these garments. Levi's tried it about 10 years ago in stores, but there are now tailors who will get you to strip down to your underwear and scan you with a 3D scanner and use measurements derived from the scan to produce your custom-fitted suit. And, you know, it's coming, right? For some reason, the vanguard is expensive men's suits, but it will come for us all eventually, maybe. For the record, that's me being printed on a MakerBot. Not a very good scan of me, but it does accurately render my pants as they were that day. Anyway, there are further examples of this. There are DIY examples. Susan brought up yesterday the example of Kyle MacDonald's project with the jeans, where you get scanned with a Kinect, and then a pattern is derived from your scan. There's one I love. There's a company, a Canadian company, in fact, that takes 3D scanners, millimeter wave scanners, which are the kind you see in airports, and puts them in malls. And you get a free account for which you only need to provide lots of personal information, and you get scanned. And because it's a millimeter wave scanner, you can go in your clothing and it will see through it by bouncing radio waves off of you. And from this wonderful scan of yourself that you get in 2 minutes in the mall, their software will tell you where you should go to buy clothing that will fit you, right? Seriously, this exists. It is a thing. Now, we already know about a lot of problems with body scanning. This, I think, is the most well-known example. What it looks like when you are inside a backscatter X-ray machine at an airport. Backscatter machines have been phased out. We're now onto millimeter wave scanners, but the results are quite similar. So that's an obvious problem, and it's the problem people like to talk about, and it's the problem people like to create rhetoric around, like calling them naked scanners, and saying, oh, they're looking at you naked. Those prurient TSA agents, they just want to see, I don't know, see your crotch, I guess? I'm not sure. But there are less obvious issues that arise when we talk about giving companies access to highly granular information about our bodies. So this is representing complexity, by the way. It's really hard to visualize complexity. So as customization gets more and more complex, in theory, it requires more and more data collection as we try to create better fits for ourselves for whatever products we're using. We need more information to do that. So beyond the creepiness factor of someone knowing a lot about you, there are problems when one discrete body scan can get connected up to an existing corpus of information about you, right? When your body, as this wonderful 3D digital object, can be connected up to your credit card history, your address, your phone number, your hobbies, the websites you visit, right? So obviously, surveillance is an issue. Another wonderfully obvious one. You all know 23andMe? It's a genetic testing service. You send a swab of your saliva to California, and they will tell you things like what diseases you might be predisposed to, or what your makeup is in terms of ethnicity, right? And 23andMe and Ancestry.com, which also now does this, is an American company in America. And we all know how American companies do when the police come asking for information about their customers, right? Sometimes they're good, sometimes they're bad, often bad. But the point here is that if you get a genetic test done for you by 23andMe by sending them a swab of your saliva, they have a swab of your saliva, and that's super important genetic information about you, right? A swab of saliva is enough to go into a police database and identify you, right? Hugely problematic. It's like giving away your fingerprints for a free movie ticket, right? It's giving away something important about you for very little return. And companies often comply with requests from law enforcement. So, beyond that, there are more basic kinds of surveillance. When you get a body scan done at a mall, and when you answer questions in order to get the free account that entitles you to the body scan, and that saves your body scans over time, maybe I'm telling them that I like biking, right? And maybe my scan shows that I have really big thighs, which would be consistent with a cyclist, and which is not new news. But maybe that helps a clothing company, and bear in mind, the clothing companies are the real customers for this data. You pay nothing, which means that you are the product, as we know. So, free like Facebook, right? So maybe that helps a clothing company make a connection between the circumference of your hips and the hobbies you like to do, right? Maybe it's good. I don't know. Maybe it's a good thing that we can all get products that fit us better. But maybe it's not. And maybe we can avoid these problems by customizing things ourselves, right? We're all skilled people here. We all do DIY, and that is rather one of the points of this. So, some things to think about going forward. How can we customize for others without surveilling? Can we be ethical in collecting increasing amounts of data about other people? How do we make the world fit us better without building perfect digital doubles of ourselves? Because this is, again, increasingly problematic. We are creating more and more spectacularly sophisticated, four-dimensional data doubles of ourselves. Big problem, right? They're fantastic representations of us. But then, is it a problem? Is it so bad to make a digital double of oneself? What are the questions of ownership in that? And is it worth it if it makes life easier, better fitting? You know, your jeans are better. Oh, fantastic. Are there knock-on problems with customizing on a one-to-one basis, though? Is it such a good thing if my jeans fit me perfectly? Can I loan my shoes to a friend if the shoes have been made specifically for my feet? What are the social problems with this? If I'm poor and need to buy secondhand clothing, what happens when everything that winds up in the secondhand store has been customized for individual people? Does that create a yet worse class striation? And what, if any, commonalities do we lose when our objects are made just for us? You know, do we lose something about the things that are good about normativity? Since, frankly, most of us are normative in many ways, and that's why mass production works at all. Finally, how do our communities of practice change when we move from customizing mass-produced objects, like the IKEA hackers do, to making fully custom objects for individuals? Should we really be thinking about de novo production for individuals, or should we be continuing to think about repurposing of existing objects? And that's where I'll leave it. Thank you.